everybody. How are we doing? Good. Awesome. Fantastic. Welcome to Agones, scaling multiplayer dedicated game servers with Kubernetes. I hope this is the session you expected. This is where you're staying, hopefully for a little while. My name is Mark Mandel. I'm a developer advocate for Google Cloud, specializing in games. And I guess technically founder of this project, I think is probably accurate. So we're going to talk today about multiplayer games, Kubernetes, containers, and other good stuff in that kind of arena. Does that sound cool? Sounds good. Awesome. I regularly give this talk at game conferences. So this is probably one of the first times I've actually given it to a wider tech event. So I'd like to know a little bit more about you, and so I know my audience and I can tailor appropriately. So people here who work in the games industry. Ooh. Actually, more than I expected. That's cool. Awesome. So people who work on, specifically on multiplayer games? Most of the same hands. All right. Awesome. Cool. All right. So very many of you who don't. That's totally cool. That's fine. We're going to look at some of that too. People who are comfortable with Docker. Most of you, but not all. That's fine too. People who are comfortable with Kubernetes. Also not all of you. That's also cool too. All right. Sweet. All right. That actually gives me a really good idea of where we want to take this and where we want to go. Excellent. So what are we talking about today? So the thing I want to talk today is about multiplayer games. And multiplayer games is a broad and far-reaching term. But I want to talk about very particular types of multiplayer games. What I want to talk about is your very competitive, online, fast-paced multiplayer games, right? So your Unreal Tournaments, your Overwatches, your Fortnites, your MMOs, your Rocket Leagues, games like that, right? Things where very fast-paced things happen between the players. And they have very particular needs, and we're going to talk about how we sort of cater towards those sort of needs with a project like Agones. To do that, I'm going to use an open source project called xonotic. Anyone here played or heard of xonotic? That is like the first hand I've ever go up, so that's awesome. Very happy. It's a really cool open source game that has very traditional FPS type gameplay, so like capture the flag, deathmatch, things like that. But it's great. It's open source, so we're going to use that as a demonstration of how we can use that on Agones for playing and scaling multiplayer games. Does that sound cool? Cool. So as you saw in the title, I use this term dedicated game server. So for those of you who aren't in the games industry, this may be something you haven't heard of before. So let's talk about what that actually means. So there are a variety of ways of making these types of multiplayer games. One of the most prevalent ways, especially amongst very large-scale games, is about what's called doing a dedicated game server. So a dedicated game server is a full simulation of the game that you're playing. So like all the physics, all the interactions between the players. And all the people who are playing said game interact or directly connect to that dedicated game server. So usually they're sending things like, hey, I'm moving forward, please let me move forward. Hey, I'm rocketing because I'm firing a rocket car or something. Maybe I'm firing a gun, maybe I'm doing all sorts of actions. And I tell the dedicated game server what it is that I want to have happen. That dedicated game server will actually simulate what's happening inside that system and then pass out what's true and what's happening from that dedicated game server back to the clients so they can render it to the people who are playing that game. There's a couple of very good reasons for doing this, one of which is latency. So games that are very fast-paced, 10 milliseconds, 20 milliseconds, 30 milliseconds of latency can be a very big deal. So having control over exactly geographically where these dedicated game servers are sitting in relation to the players that are playing them gives you a lot of control and gives you a player experience that you can rely on. And this is a good thing, right? We can't control the speed of light. It'd be really nice if we could. So having that geographic location-based system is really, really nice for the players. On top of that, I might let you in on a little secret. I don't know if you've noticed this, but some people are really horrible. I don't know. Maybe you haven't noticed. I don't know. Maybe. That's great. And if you haven't, that's wonderful. But as soon as you hand someone a binary with traffic they can introspect, people tend to do that. They tend to have a look at what the traffic is. They tend to have a look at the binary. They try and play with it and mess around with it. Basically, they try and cheat. Having a dedicated game server that sits on your own network can mitigate some aspects of that too, so that gives you some leg up in that way as well. We're not going to talk about that much, but it's something to consider. So dedicated game servers are good, and because they mitigate cheating, right, the idea is that they're authoritative. Right? They are the source of truth about what is happening inside a game. I say that I shot that person over there. It is the dedicated game server's job to say, hey, that actually happened in the way that you expected it to. The way I like to think of it is each of the client asks to do something, and the dedicated game server's job is to tell. Right? This is actually what's happening. So cool. We have a bit of an idea about dedicated game servers and how they work. Awesome. So traditionally, how are these things architected? So you might have, say, in a typical like session-based game, like say somebody's playing like Capture the Flag or something like that, you might have two more people who are like, I want to play a game. So they sort of declare they want to play a game. And they're going to talk to some kind of matchmaker. That matchmaker is probably going to pair them based on skill level, maybe their social graph, stuff like that. And once they've got a pairing or a match of some kind, they're going to talk to some kind of server manager. This server manager's job is basically to be like, hey, you need a game server to run on, and then you can all connect to. So it'll then talk to a potentially very large cluster of machines, potentially spanning the globe. Be like, OK, this machine's the good machine. Awesome. We like this one. It's got enough resources. Sweet. Let's spin up a process on it. Let's set up a game server. We'll find a port that's free. Fantastic. All right, so now we have an IP and port where like these games they've been playing it on. Now we can send that back up the pipe all the way up through the matchmaker to those two players, and they can make a direct connection to the game. Right? Direct connections here are important because latency, right? We don't want to go through a load balancer. Also, that full simulation state is in there, right? So we can make direct connections and everything that happens inside that machine. So that's basically how a lot of very traditional big multiplayer FPS, very fast-paced games work. The part that I want to talk about today, though, is this part here. This is where Agones kind of comes in, right? So we're not talking about like the matchmaker, but what we're talking about is the system that says, oh, I need a game server, but where in this cluster should I put it? Where should I run it, right? That kind of stuff. How do I spin it up? How do I spin it down? That kind of thing. And this is really the kind of problem that Agones is trying to solve. Cool. So Agones, what we're talking about. Although apparently if I say it right, it should be Agones. We should have a rolling R. I've been told by people who say Greek. So this is an open source project that technically we started back in November, though we only announced it earlier this year, for running, scaling, hosting dedicated game servers for multiplayer games. I'm pretty excited about it, and I think it's really cool. So I'm glad that you all came here to hang out with me today to hear all about it. The thing that's really cool about this as well, we aren't doing this alone. So this is a Google Cloud-led project, except for the fact that we are doing it with a wonderful collaboration with Ubisoft. They've really brought to the table their long-term experience in running multiplayer games at scale, and they've been doing it for a really long time. From the title, as you see, we've been building this on top of Kubernetes. We've been able to build the experience we have with running containers and building Kubernetes. And it's been a really lovely meeting of minds, I feel like. They're lovely people, and I can't say enough nice things about them, actually. Sweet. So let's actually get into how does this thing work, and we'll look at some code, and how do we actually make this thing happen, and stop talking theoretical and get actually practical. Does that sound cool? Yeah? Awesome. Awesome. So potentially unsurprisingly, we're going to talk about containers. So we reuse a lot of what Kubernetes gives us out of the box. So first step for taking our dedicated game server, right? So say we've written a dedicated game server. Maybe we've done it ourselves. We've used Unity. We've used Unreal. Really, the first step is basically we put it inside a container. There's nothing really special going on here. But I want to talk about containers for a bit too, especially those people who aren't familiar with it. So if you haven't really worked with containers much, the part that I find most exciting, the part that I think is most relevant here as well, is that really containers are a standard. Right? They enable you to take a set of software and build an artifact that is transportable, that is runnable, all through a standard set of interfaces. So we use this analogy a lot of like an actual shipping container, but I feel it's really apt. Right? So it doesn't matter whether I'm running a game server running in .NET or C++ or Java or Node. I don't care. It's in a container. That's great. In the same way with a shipping container, I don't care if it's a Ferrari or a whole bunch of chairs or, I don't know, tablecloths. I can pick it up with the same cranes. I can put it on the same truck. I can put it, in the same ships. Everything is fine as long as it fits that standard. And so this is true here too, right? Because we can put our game server inside a container, we can put whatever we want inside it, whatever systems you need inside it. This is our basic building block, and it means that we can do very generic stuff with it that we need to do for both game servers as much as we would for any other types of software. How do I get new versions of it? How do I get my logs out of it? How do I know if it's running? Right? These are all standard problems for everybody. So to prove to you that I'm not twisting your arm or anything, this is essentially the Dockerfile for running Xonotic. If you haven't written Dockerfiles before, they're fairly imperative. They have a series of commands. We do them. You start from the top. Many of you have done this, so this is probably not new for you. We start from the top, so we say, hey, let's start from Debian, just start from a Linux instance. And then we download Xonotic, and we move some files around. Basically, Xonotic requires us to put in this server linux.sh in the right spot, so it'll run as a dedicated game server instead. And then we set an entry point, which basically says, when you've created an image from this Dockerfile and you run it, run this thing. So there's nothing really special here. I just want to be clear about this. I am slightly hand-wavy. I'll admit this up front if people have actually worked with Agones. There is an SDK that is built into Agones for doing standard game server lifecycle things. It's one of the things it gives you out of the box. So hey, this game server's ready, health checks, things like that. I'm going to be hand-wavy about that here. We actually do some wrapping stuff for Xonotic because I don't want to touch the code. So it's fine. But that does exist. But essentially here, this is just a Docker container. There's nothing special here. We're not removing any capabilities. We're not adding anything. It's just a standard Docker container. So anything you can put in here. So again, for those who aren't as familiar with Docker, once we have this Docker file, we're able to create a Docker image. Right? This is something we can tag, we can version, and then we can share this around with a registry. Right? If you're not familiar with Docker, again, this is the thing that lets you do, hey, this is a new version. I want this to go out live. Who can grab a copy of this? If I download this image, is it the right image? Is it the one that I expect it to be? That kind of stuff. So all that stuff that you have when you're like, oh, I have a game server. I would like to update it. Those sort of problems are essentially solved just by using the standard tooling. So nothing too special there on the Agones land, but I just want to set a kind of baseline and that Docker knowledge. So to prove to you that it works, if I can switch to demo, please. Thank you very much. I'm going to run my server. So I'm actually running, we're talking about the SDK. I'm actually running the local version of the SDK here, so I'm just going to run this from here. But to prove to you, like, Docker run, that's Xonotic running. I know that doesn't look like much, but I just want to be really clear about something. I didn't run the specific commands I needed to care about for Xonotic. I just ran Docker run, and that's really powerful, right? That's the abstraction I'm talking about. That's really nice, because as long as I run Docker run, my server runs, everything is good. That makes me happy. Cool. So that's like super baseline Docker stuff, but from a game server perspective. If we can switch back to the slides, that'd be awesome. Thank you. OK. So we have a game server. Probably we've integrated the SDK, which is great. We put it inside a container. Fine. Right? Nothing too special. But we don't want just 4 players. We want lots of players. Lots of players good. For some reason, only having 1 player or 2 players doesn't pay the bills. I don't know why. But it'd be nice if we had lots and lots of players. So this is where we step into the land of Kubernetes. So you've probably heard this word a lot, being here at Google Cloud Next, which is not surprising. If you're not familiar with this at all, which is totally fine, think about it. The most simplest way I can ever explain Kubernetes is that it is an open source project for running processes over thousands of machines, or even less, just over big clusters of machines. If this sounds familiar compared to what it is we were talking about previously, there's a reason for that. Kubernetes is really important to Agones, and I want to talk about it for a couple of reasons. One, because it's kind of amazing in what it enables you to do, because out of the box, it gives you things like, hey, I want to run these processes, I want to run 10 of them, make sure they're up, make sure they stay up, let me do log aggregation, lots of really good stuff just straight out of the box. The big thing that's really important about Kubernetes and why it's important as well for games and game servers is that it is an open standard for basically running infrastructure. So you might come out of the gate and you're like, awesome, I'm going to run my game servers on top of Agones, and we're going to stick it on GKE, and it's going to be awesome. Right? We're going to use Google Cloud, and it's great. And then you discover that in some pocket of the world, you have a really fervent player base. And then you're like, oh, well, Kubernetes is great, but GKE doesn't seem to cover it. Let's look at some other cloud providers. Maybe they do, maybe they don't. And then you're like, you know what would be great? It would be great if I could just set up a little colo somewhere, like buy some hardware, put my game servers there, because then they're going to have the best game experience they can have, because latency matters. So wouldn't it be great if I just had a platform where I could basically pick this up and put this wherever I want? This is what Kubernetes gives us, which is amazing, right? So Kubernetes is the standard. You might come to us and be like, GKE is great, awesome, but sometimes I also want to run on my own hardware, right? Maybe I want to run GKE on-prem. That's pretty cool. I'm really excited about that, by the way. Or maybe I just want to be able to put it, into particular places. So once you have Kubernetes, that means that you can run Agones on top of it. And yeah, that gives you the flexibility to run your workload for your games and your game servers in exactly the right place that it makes sense for your players. And that gets me really excited, too, because that means we can all play better games, which I like playing games. I don't know about you. It makes things fun. So let's look at how this works. The other part of what Kubernetes gives us as well is some really amazing abilities to extend it. right? So there's people who are familiar with Kubernetes. You've probably seen like deployments, you've seen services, you've seen pods, like you've seen these sort of nouns of things that exist inside Kubernetes. And you get into the world of what's called custom resource definitions and controllers, which is a term if you want to completely forget, that's totally fine. You get into this realm where you're able to add your own nouns to Kubernetes and tell it how to handle them. Right? So it knows how to handle web server type experiences. You do a deployment, run 10 of them. If one of them dies, don't care. But what we want is we want an experience that works for game servers. We want to be like, hey, fire up this game server, but let me know when like it's ready to accept player connections. That's something I care about. Make sure there's health checking that makes sense for a game server, right? Before players have connected, you can restart. That's OK. But once players are connected, don't restart, because otherwise weird stuff can happen when players reconnect to game servers that have 0 state. Like, that's all weird. So stuff like that. Right? So we're able to extend Kubernetes both from a YAML perspective, but it also extends the backing API as well. So I'm going to do a bunch of stuff here as well. With Agones, that we're going to use YAML, which is the pretty standard way of doing stuff with Kubernetes. But anything you see me doing with YAML and kubectl, I can do through an API as well. I can do it all through the Kubernetes API. So just keep that in mind. Anyway, so if we want to fire up a game server, right, in this case, the Xonotic game server, how do I do that? Once I've installed Agones, I can create this thing called a game server. It's really that simple. How does that work? So I say game server. I can give it a name. I can also tell Kubernetes to generate a game server name for me if I want. That's just part of Kubernetes. And then I've got very game server specific things, like what ports do you want to open on this so that I can connect to it? Now, we do direct connections with dedicated game servers. That's not something that Kubernetes gives you out of the box. This is something that Agones will handle for you. So we'll do allocation of ports for you so that you don't have to worry about that yourself. And we do that port routing as well for you, make life nice and easy. So we do port management. You can do multiple ports. And then we can do a set of containers. Right? So here, this is the game server container, Xonotic 0.3. For those of you who are more familiar with Kubernetes, what's available here is actually a full pod spec as well. So anything you can do with a pod, you can do inside Agones as well. So if you want to do like volume mounts, secret mounts, config management, all that stuff, that's all available. Multiple containers, et cetera, et cetera. For those of you not so familiar, don't worry about it. You can run a container. So here we're running the Xonotic example tag running out of the Google Cloud Registry here instead. And so this gives us the ability to run a game server. So if we can switch back over to demo, let's run one. Does that sound like fun? Awesome. So here I have up top Weave Scope, which is a great visualization. I'm going to install Agones first. We have a Helm chart for that, although you can use an install YAML. Let's see if I get this right. Helm install name equals Agones, namespace equals Agones system. Cool. Install Helm Agones. I think I got that right. So it should spit back a whole bunch of stuff. See, my internet works? Good. That actually looks right. That's good. It should show me a controller at some point soon. Go on, I saw something happen. There we go. OK, so that's up and running. So that's basically me installing Agones. It's not particularly complicated. Right? Pretty straightforward, which is quite nice. And now everything's available to me to run a game server. So let's just have a look at pods here. I'm going to go into the default namespace, which is where I'm going to create my game server. Again, everything, so I'm just going to do a kubectl apply. So this is going to apply the game server configuration we saw previously. So what am I doing? I'm doing example Xonotic. And I want it to run as a game server YAML. So we now have a game server that's been created. And you'll see that it says the word game server there. What's really cool, if you've never looked at any of this extension stuff, I can say get game server, for example, and it understands what game server is. I can even describe this. This is going to show a bunch of stuff. Game server, and it'll give me code completion as well, which is also super nice. But I'm not going to look at that right now. So we can see that Xonotic's running. If we want to, we can have a look at its logs. There's a bunch of stuff happening. Great. I can see there's a bunch of messages coming out. So that's all up and running, which is lovely. If I describe, I can see there's a bunch of events. We get a bunch of status data. Oh my god, that's really hard to see. OK, so we're not going to do it that way. Here's a cute thing that I really like. Anyone use kubectl and get custom columns? I really like this. You can do your own kubectl commands that give you custom columns. So this gives us a really nice thing. So when we fired up a game server, Xonotic's going to fire it up, allocate it a port. So we can actually have multiple ports, so it comes out as a map. And it'll give us the IP address, and it'll give us a status as well, right? When a game server is ready, it marks itself as ready, so it's good to go. So that's cool. We can fire up a game server. That's pretty neat. It gives us an IP import. We can see that it's running. But we can do more than this. So let's actually delete this game server. GS is just the shorthand for game server. And we'll come back over to the slides. We come back over to the slides, please. Thank you. Excellent. OK, so we can do more. But let's just have a quick look. So we saw the previous architecture, right? We were like a couple players who want to play with a matchmaker, right? So maybe we have a custom matchmaker, possibly the new open source matchmaker that's coming out later this year. That'd be cool that we're doing. And instead of talking to some server manager, we instead talk to the Kubernetes API. And we can say, Kubernetes API, please create me a game server. Right? And Kubernetes is declarative like this, which is nice too. Right? So we tell it what we want, and it goes ahead and does it. We would like a game server. Create one for me, please. And it'll do that. It'll create a dedicated game server, send back the IP import. We can send that back up the pipe, and our friends can play a game. But like I said, we can do more. Sometimes, in fact, oftentimes, we don't want to fire these up one at a time. What we want to do instead is have a large group of them, right? So very much like if you've used Kubernetes before, instead of having like just individual pods, what we really want is a deployment, right? So what we have instead is we also have what's called a fleet. So hey, I would like to have a pool of 100 game servers, please, that are all up and ready. And then when the player wants to play with them, I would like you to pull one out of the fleet and hand it over to me, and then I can set players to play a game so that I don't have to wait. That'd be sweet. And then I can keep track of what's in the fleet, and I know what my players are doing, and everything's good. And there's some other cool stuff that we'll look at in here, too. So if you've ever played with deployments, this probably looks fairly familiar. This is just another extension. So we have a fleet. It looks like a game server, except we just specify how many replicas we want, and then we specify what we want our game server to look like. So here we have 2, and we have a game server that looks pretty much exactly as it was before. Nothing really different, other than we're specifying that we want lots of them. Cool. But you may be asking a very interesting question, which is a good question indeed. We don't have load balancers, right? How do we pull a game server out from this set and be like, I would like one of these, please. Can I have one, please? So we have a thing called a fleet allocation. Now, this is just one way you can do this. We have a full API, so you can do a whole bunch of different types of workflows, just so it's clear. But this is what we prefer, at least right now. So we're able to say, hey, Kubernetes, give me a fleet allocation out of this particular fleet. And it's going to respond with a game server that's actually marked as allocated as well. This is quite nice. So it'll do all the management of those game servers, be able to look through them all and be like, hey, let's see if there's one that's ready and available and waiting for you. And then if there is, it's going to pull it out and be like, cool, I'm going to mark that as allocated, and then I'm going to give that back to you. Now, allocated is special, and we'll look at that in a minute. Let's head over to demo land again, and we'll play some more. Excellent. So let's fire up a fleet so we can just have a quick look at it. We'll apply -f examples xonotic fleet, and this is basically exactly what we had before. So I'm going to create 2 instances of this game server. We'll see they come up relatively fast, which is nice. If we run that command that we were running previously, we can see there's 2 of them. They're ready. They're running on different ports. They're running on the same node. That's fine. That's cool. OK. And we can do very similar things to what we had previously. Like, for example, sorry, not what we had previously, but if you use deployments, for example, we can edit our fleet. It's called xonotic. And we'll be like, let's make that bigger. If we were like, hey, I would actually like 10, we can make that happen. For those more familiar with Kubernetes, at some point in the near future, we'll make it so you can kubectl scale. That'll happen. But we've asked for 10. Oh, here we go. Yep, and there's a whole bunch of them getting created. Whee! So we can scale these up and down, which is really nice. But let's allocate and have a look at exactly what happens when we start allocating stuff out. Boom. So we'll have a quick review. So let's run this command. All right, so we can see they're all ready. That's good. We have 10 of them. Sweet. So let's allocate. So this is something you would probably end up doing through an API command. So you probably allocate from your matchmaker and be like, hey, give me one so I have people who can play a game. But from here, I'm just going to show it to you with YAML. If you ever want to get the results out of YAML, just do that. It'll spit it back out at you. going to spit out a lot of stuff at us. So actually, let's make that bigger. So that's because I wrote the wrong thing. That's fine. We're writing demos. It's fun. All right. We want to create this. OK, so I've got that. That's fine. We want to explicitly create it. Let's do that. OK, that's better. All right. So this is spitting back all of the stuff. Oh my god, so much. So I'm going to ignore most of it. Spinning it back, we'll see we have a status. It gives us back a game server right here. But the bit that I care about really is this bit down here at the bottom, where I say status, right? So it's giving me back the game server. So we looked at that before when I ran the command. It gives us an IP address. It gives us the port. And it gives us the state allocated. This is kind of the big thing, I think, with Agones and with game servers, and it's kind of the tricky part about it. We sort of talked about it before, right? So before players connect to a game, we don't care about that game server. So I could scale this fleet down to 0, and it would kill all of them, because there's no players connected, and that's great. But as soon as we're allocated, we're assuming that there are players connected right now, and you do not want to delete that game server, because for some silly reason, players get mad when you cut off their game halfway through. So let's try not to make that happen. And this is one of the big things I think Agones really gives us. So let's actually, I'm not going to do that. Let's allocate a whole bunch. And I'll prove to you that I'm not 100% lying. All right, so sweet. We can see we have 4 allocated, for example. What happens at this point if we want to scale back down at this point? Right? So if we want to kubectl edit our fleet again, what is it called? Xonotic? There we go. And we want to bring this down to 3. And that's going to take a little while, because those game servers take a little while to shut down. But if I actually look at the pods, which is like the backing containers that are running, we'll see that most of them are terminating, right? So these things are shutting down, but we still have 4 that are running. Even though we've told it we want to go down to 2, it's going to go down to 4. And this also applies for when you want to do updates as well. So fleets manage updates for you as well. We're not going to look at that today. But say I want to have a whole new version of a game server, and I want to roll that out. I can do that. I can do a kubectl edit, or do a apply of a new version, et cetera, et cetera. Usual stuff. And it'll go, cool, we're going to have a new version come through. Excellent. So it'll stop pushing that version through. But the game servers that are currently connected and are allocated, it's going to leave them alone until they shut themselves down. So this is really important stuff, and kind of different from how a lot of other applications work. So if we have a look here again, cool, we can start to see like this is starting to disappear. But we still have those allocated servers, and they're never going to go away until we're finished. OK, let's play a game. Like, that's kind of what we're here for, right? Video games are fun. So let's grab one of these. Not the unhealthy one. That would be bad. There we go. Let's grab the top one. Actually, I don't need to do that. I've got the IP address here. So I've got an IP address here for one of these on a port. There's a port open on 7791. So let's pop over here. Run this. OK, that's going to pop up. Oh, we'll turn that off, because that's just distracting. Now, the other fun question is, I can't see my IP import. That's hilarious. I didn't think of that. Anyway, that's fine. 35197 5.197 dot. We'll just move this over again. 197.42 dot 36. Did I type that right? Nope. 197.42. No. Oh my god. I did not do this well. OK, that's fine. kubectl describe game server xonotic. This will put it on the left. HD8. Oh, there we go. Okay. There we go. Now I can just scroll up a little. Perfect. I have done this once where I actually took a photo of it and then did it that way. And it worked. It was fine. 35.197.42.36. 7791. All right. Litmus test. Will this work? Black screen is actually good. I don't know why they made the game that way. Just to give me a heart attack. So this is connecting to a GKE server. So like I said, we ran a fleet. It's fired it up. It's found a port for it. It's allocated to a particular node in the cluster. Here we go. And given us a game server, it's allocated itself as ready. And now I have to play on my trackpad and find, come on, there are like 4 other bots in here somewhere. Do you know something? I don't think I've actually played on this level before. I'm playing, come on, just show me another player. All I want is like 1 other player somewhere in here. Of course, I can't find a single soul. literally as soon as I'm in front of a whole group of people. There we go. But there we go. Yay! All right. So here we are. We're playing. So this is me running Agones on a cluster on GKE that's somewhere around here on the East Coast or the West Coast. And so it actually works. Cool. Cool. So that's it actually working, which is also cool too. Awesome. OK, so let's move back to the slides again, please. Fantastic. OK, so this is kind of cool. This means that we have a very similar architecture to what we were looking at previously with just spinning up game servers. But now we have a warm fleet, which is really nice. So that means then when we run this thing, we can say to Agones, hey, we have this fleet. Give me one of these out of this fleet. And it'll pull one out of the fleet for me with the appropriate locking and the appropriate atomicity. And we can send that information back up, and these people can play a game as well. But the nice thing here, and I kind of want to highlight it as well, is these are layers on top of layers, right? So if in the same way as with Kubernetes, if you're like, I like pods, but I don't want to deal with deployments for whatever reason, or you want to do something very specific, we can do stuff. If you're like, I don't like the way fleets work, you can interact directly with game servers, or you could manipulate fleets in some very interesting ways as well. So we're trying to build that flexibility in. You can do some really neat things. So where are we going in the future with this thing, right? So technically today, I was meant to put out the 0.3.0 release, because that's where it is in the calendar. Next kind of got in the way a little bit. It should happen today, I think, maybe. But the 0.3.0 RC candidate came out last week. So we're on a 6-week rotating release cycle, so that's working out really nicely. So we have a bunch of stuff coming. The next big ticket items are statistic collection and display. So we want to do very standard stuff like player count, how many game servers, how many game servers we had over time, et cetera. But we also want to do very game server specific statistic collection and display as well, right? So frame rate, hitching, right? So we want to be able to look at exactly what those are, very, very particular things that you want. We want to have those baked in because basically everyone needs these things. We're going to look at autoscaling. Autoscaling has some very unique and interesting problems to game servers as well that are very different from other things. As we looked before, you can't shut down nodes where people are playing games. They get mad. So we need to look at that. And there's also some interesting statistical stuff that we can play with there. We want to have some better commercial engine integrations. So we've got a lot of interest specifically around Unreal as well for doing this. And we're actively working on that right now. We've got SDKs for C++, for Go, for Rust, which actually got dropped by the other day, which was really cool. But we've also opened it up now. The whole SDK system is built on gRPC, but we've opened it up to REST as well. So if you can send either gRPC or HTTP/JSON, you can build an integration. It's pretty straightforward, which is quite nice. We are actively looking at Windows hosting. So Windows is pretty big in the games industry, strangely enough. So there's been some wonderful work by a lot of people who are doing work with Kubernetes and Windows that we're looking to rely on. So we want to make sure that that's as well supported as we can make it as well. Finally, all the way down the line, we definitely want to be supporting multi-cluster. SIG multi-cluster is the group that does a lot of the multi-cluster work, so we want to make it easy and available for you to run multiple clusters around the globe. We also want to build tooling into that as well. So like, what are my ping times from these clusters? Are these clusters available, being able to take them down? So you can do that round trip time, so you know what your latencies are between the clusters. Again, just standard stuff that people are going to need. Cool. So what do we do today? Just to kind of wrap things up in a nice, pretty bow. So we took our dedicated game servers, right? We were talking about that, right? We don't care what language they're in, right? As long as they can interact with our SDK, which pretty much everything can, which is great. We stuck them inside a container, so we're good, right? You can put whatever you want in there, which is great. It gives you the flexibility to do pretty much whatever you need with your dedicated game server. Then we took that container and we stuck it on top of Agones, which is nice. So now we can scale this, right? We can scale this out to thousands of machines. We can run thousands of game servers, so we can support lots and lots and lots and lots of players, which is good, because lots of players, they like spending money, which is good. If you want to learn more, agones.dev will take you directly to the GitHub repository. We should have a fancy new website in maybe about a month or so. We're working on that too. Agones Dev on Twitter as well. We've got a mailing list. We've got a very active, well, reasonably active Slack channel where we like to talk about this stuff a lot. We are definitely actively looking for contributors in any way, shape, and form. So if you're interested, come into Slack and just be like, hey, I'd like to help. That'd be great. For obvious reasons, if you're interested in Kubernetes, Kubernetes.io, et cetera, and that kind of stuff as well. I don't know if you noticed I wear this T-shirt. It says something like Google Cloud Platform Podcast. So it'd be remiss if I didn't take the opportunity to like spruik that a little. So if you find me at least vaguely entertaining, myself and Melanie Warwick run a podcast called Google Cloud Platform Podcast. where we talk about all sorts of things cloud, including game stuff, and sort of Kubernetes stuff, machine learning, all sorts of other stuff along those lines as well. I will reiterate, if you do have questions and you don't get to them today, my business cards are sitting right there, so please feel free to come up and grab some and come swing by. My DMs are open on Twitter. You can hit me up on email, anything like that. So if you don't think of anything at this particular point in time, I'm open and interested in hearing your opinions and questions. Finally, thank you very much for coming and hanging out with me today. I know your time is valuable, and I appreciate that you decided to spend it with me, so thank you very much.